Okay, guys, so welcome back. I hope you got a chance to relax over the spring break. I know that because of quarantine, none of us really got to enjoy the way we were hoping to do so. But it's always nice to get that 1 week off and relax a little bit. So we're gonna proceed now with school, and I am gonna start a new chapter. So this one is trig. So again, trig is usually um, not that difficult of a unit. But you guys are in grade 11, so it's going to be a little bit challenging. At first, it's going to be easy. Today's class hopefully will not be too difficult. But I think um, it's better for me to just to give you a heads up that it might get a little bit challenging. So I don't want you to underestimate this unit, okay? So for the starter question, I'm just going to ask you to pause the video and answer this question. So draw a Cartesian plane and label the four coordinates. So Cartesian plane is your XY plane, right? So this is X and that is Y, and I'm just asking you to label the quadrants, okay? And this will make more sense. Well, hopefully this kind of makes sense to you, right? Because we're gonna extend on this logic, okay? So please pause the video and then proceed, but I'm gonna go ahead anyway. So quadrant one, right? This is the one that we use all the time. So hopefully you know that this is quadrant one. Now, the thing is, you have to move in counterclockwise direction, okay? So this way, okay? This is what we mean by counterclockwise, right? Because the clock moves in the other direction. So if this is one, then this has to be two, right? If you're moving in counterclockwise direction, this is three, and this is four, okay? So these are your quadrants. And we're gonna kind of like extend on this fact a little bit when we do trig this year, okay? So last year we, you probably worked with triangles and there was no, quadrants, nothing like that involved. This year there will be, okay? So it's make sure you know this stuff, okay? Um, so let's continue on to the next page. So this year, the difference, I guess, is that now we're going to be placing angles inside a Cartesian plane. And you need to know some definitions, okay? You need to know what a standard position means. So standard position measures the angle, but it always starts from the initial arm, which is on your x-axis, okay? So in a similar fashion, when we talk about angle, we talk about degrees, right? So this, you can think of this x-axis as your 0 degree over here on the right side, right? And because you're moving in counterclockwise direction, this is 90 degrees, right? And then another 90, so this makes it 180 degrees. This is 270 degrees. And then, when you make a full circle, right, you're at 360, okay? So 0 degrees, 360, they're equivalent, okay? And that will make sense when we start doing sine, cos, and stuff like that. But what you really have to understand is that you're moving in counterclockwise direction. Um, and you're always starting from your positive x-axis. Okay, so that's 0 degrees. So this is 0, this is 90, 180, 270, and 360. Okay, so that stuff is super important. So how do you measure standard angle? It always starts from the positive x-axis and goes all the way up to what we call the terminal arm. Okay, so initial arm, terminal arm, fancy words. You don't need to really know what initial and terminal arm really means. But questions in the textbook will use those words. What you really need to understand is that whenever you're measuring angle in standard position, you're always starting from the positive x-axis, right, which is what they call initial arm, and you're going all the way up to where the terminal arm is. Okay, and now I'm going to give you an example, which will hopefully make more sense. So let's say the angle measures 30 degrees, okay? And I'm asking you to draw this angle. So you're going to draw your xy plane. So this is x, that is y. You're going to start from here, okay? So this is 0. Um, so 30 is less than 90, so it obviously has to be in the first quadrant, right? So it has to be in this quadrant. And 30 is less than 45, so maybe something like this, okay? And this is your, let's just call this theta. Okay, so this is theta. Okay, that's your 30 degrees, okay? Approximately, okay? Now, you have to be careful because this respects the definition of standard position, right? Starts from the initial arm is on the positive x-axis, the terminal arm is here, and the the distance in between is what we call theta. Okay. Um, Now, so this is in standard position. Okay, so I'm going to give you an example of something that's in standard position. And the other example will not be in standard position. Okay, so you know what? Let me just yeah, so let me just check this. So this is in standard position, and I'll just maybe use a different color or something. Okay, so this is in standard position. Now, theta, let's say if theta is yeah, maybe not blue, something else. So let's go with green. What if theta is equal to, let's say, 60 degrees, okay? Now, if someone gave you, right, this is the XY plane, and someone did this, okay? So this, and then they called this theta. It does look like 60, right? Because this, so theta is equals to 60 degrees. So it's, no, that's not wrong, right? So this angle, like maybe, I'm just using an approximation, but if you use your protractor or something, it might actually work out to be 60, this angle over here. But you see, the problem over here is this is not in standard position, okay? In standard position, your angle has to start from the positive x-axis. It has to start from here and then go to your terminal arm, okay? So in the standard position, your angle would be 30 degrees, okay, not 60, okay? Because remember, 30 and 60, right? If you add them up, is 60 and 30, they should give you 90, okay? Because this is a right angle. So this is not in standard position, okay? The 60 degrees, even though it's 60, it's not wrong. It's 60. That the 60 does make sense, but it's not in standard position, okay? So this is not in standard position. Okay, so that's why I'm just gonna cross this out. Okay, so this is in standard position, but this one is not in standard position. Okay, so now let's do some quick examples. So sketch each angle in standard position, right? Keyword here, standard position. State the quadrant in which the terminal arm lies. Okay, so 36 degrees, very quickly, right? So this is your XY plane. Y, this is X. So 36 is less than 90. It's less than 45, so we'll be less than halfway. Okay, so this is 36 degrees. Okay, this is what 36 degrees will look like, and this is obviously in quadrant. So it says state the quadrant in which the terminal arm lies. So the terminal arm is in quadrant 1. Okay, now for question B. So this is question A. Question B, let's just do it here. So again, you draw your XY plane. X, Y, and now you have 210. Okay, so you start from here, right? This is where you always start from. So this is 0, this is 90, this is 180, and this is 270. So it has to be in between 270 and 180, right? So it has to be in the third quadrant. So let me make this look a little nicer. Okay. Now, if this is 180, then 30 more than that will be 210, right? So maybe something like this, okay? And now this is your angle. It starts from, maybe let me use a different color. So it starts from here, right? And it goes all the way there, okay? So this is 210 degrees, okay? And let me see if I have enough space for the last question. So I'm just going to do it right over here. So again, draw your XY plane. So this one is 315, X, Y, right? So 90, 180, 270, 360. So 270 plus 30 is 300. So this is kind of like halfway, right? I think exactly halfway. So maybe let me use a different color. So because I think 315 plus 14 is 360. So this is exactly halfway. Okay, so again, your angle starts from here, right? Starts from the positive x-axis and goes all the way there. Okay, so this is your 315-degree angle, okay, in standard position. Okay, so that's what it means. You just need to know that you always start from the positive x-axis and then you go to wherever your terminal arm is. So, oh yeah, I forgot to label the quadrant. So this guy over here is in quadrant 3, where the terminal arm is in quadrant 3, and this one is in quadrant 4. Okay. So hopefully that kind of makes sense. So now what I'm going to ask you to do is I'm going to ask you to do these 3 questions on your own. So just pause the video, draw these angles. Again, they are in standard position and you have to state the quadrant, okay? So here I'm not going to be explaining too much. So pause the video. I'm just going to show you the answers, okay? So 150, right? Actually, you know what? Yeah, so this is question A. Let's do it exactly the way I did those questions. So um, you don't have to put the X and Y, I guess, but if you want to, you could. You don't have to. So 180 is here, so 150 is 30 less, so something like this. Okay, so this is your 150-degree angle. Part B, question B, draw your XY plane. Okay, again, you could put the X and Y, you don't have to. 60 is less than 90, but it's more than halfway, so maybe something like this. Okay, so this is your 60-degree angle. And then finally 240, so draw your XY plane. Right, 240 is more than 180, but it's less than 270, so it has to be in quadrant 3. And it's exactly 30 less than 270, so something like this, okay? So this starts from here, goes all the way there, and this is 240 degrees, okay? Oops. Okay, I'm gonna make this look a little nicer. Okay, so these are your answers. Hopefully this is what you got. And now you have to label the quadrant, right? Which is something that I always tend to forget. So this is quadrant 2. This is quadrant 1. And this is in quadrant 3, okay? Hopefully that kind of made sense. Now, reference angle. Okay, so as you can see, these standard angles can always have a reference angle. So what does reference angle mean? This is the fancy definition given to you in the textbook. But what it basically means is it's the angle between the terminal arm and the x-axis. Okay, so angle between terminal arm and x-axis, okay, and x-axis. So if the standard angle is 230, calculate the reference angle. So let's draw your x and y Cartesian plane, right? So this is x, that's y. 230, that means it's more than 180, but it's less than 360. So 180 plus 50, right? So it's more than half, so maybe somewhere here, okay? So this is your angle, okay? This is your standard angle, 230 degrees. But your reference angle is the angle between the terminal arm and the x-axis. So this is your x-axis in blue, right? And this is your terminal angle. So it has to be the angle in between. So we're talking about this guy, right? We're talking about this angle. So we call this theta r for reference. Now, how do you calculate that? You always have to look at which one's bigger. Is your terminal arm, the angle of your terminal arm, bigger than this 180? And it is, right? Because this is 280, this is 230 and this is 180. So theta r will always be whatever is bigger minus the smaller one. So it's just going to be 230 minus 180, which is equals to 50 degrees, okay? So that's how you find the reference angle. Key thing is this definition over here, okay? It's the angle between the terminal arm and the x-axis, not the y-axis, right? If we're talking about the y-axis, then this would have been your um, reference angle, right? It's not the y-axis. The keyword here is the x-axis, okay? So let's practice a little bit. So determine the reference angle for each theta, sketch theta in standard position, and label um, the reference angle as theta r. Okay, so we have to do two things. Okay, so let's draw the standard angle first. So xy plane, right? X, y. 130 is less than 180. It's more than 90. So somewhere maybe here, okay? So it's like 40 degrees more than 90, right? So this is 130 degrees, okay? And this is your standard. So I'm gonna use the um, data in standard position. So I'm gonna use red for standard and then blue for reference. So reference angle again. So this is my x-axis. It has to be the angle between the x-axis and the terminal arm. So we're talking about this angle. So this is theta r. Now you have to ask yourself, which one is bigger? Is your x-axis bigger, or is this angle bigger? And it turns out the x-axis is bigger, okay? Because this is 180, this is only 130. You always have to do bigger minus smaller, okay? Because you don't want to get negative angles, okay? So theta r will just equals to the bigger angle, right, which is this 180, minus the smaller angle, which is 130. And if you do that, you get 50 degrees again, okay? So for question B, let's remove this a little bit. Let's make some space. So this is X. Now let's do question B. So I'm just gonna maybe separate the two. So let's just draw a green line in between. Okay, so 300 degrees. So again, draw your Cartesian plane XY, right? X, Y. Um, Start with 0, 90, 180, 270. So this is more than 270, exactly 30 more, right? So maybe something like this. It has to start at the origin, right? So this is maybe not the perfect drawing, but maybe something, it's kind of hard to do that on the iPad, but it has to start at the origin, okay? So let's just say that that's close enough. So this is 300 degrees, right? So that's your standard um, position. But remember, reference angle has to be between the x-axis and the terminal arm. Okay, so this is the angle that I'm interested in, theta r. Now, so how do you find theta r? You have to do the bigger one. So which arm is bigger? This one, which is at 360, or this one, which is at 300? So 360 is bigger, so theta r will just equals to 360 minus this one, which is 300. And that gives you 60 degrees, okay? So that's how you find the reference angle. Now, I'm going to ask you to find the reference angle for these two questions. And then I'll assign you your homework, okay? So today's class is not going to be that long because I really want you to understand this. It's as easy as it seems. It might throw some of you off. And if you don't understand this, then tomorrow's class and Wednesday's class, which is going to be a lot more difficult, will give you a hard time, okay? So let's do, again, you know what, let me just draw the green line in between so that I can manage my space a little better than I did in the previous question. So, just draw your XY plane, right? So this is X, that is Y. 75 is less than 90, but it's more than halfway. So maybe something like this, okay? So this is 75 degrees, right? 75 degrees. Now, okay, the reference angle has to be between the x-axis and your terminal arm, okay? So some of you might have confused yourself. Is it, and that's a good question to ask. Is it between this terminal arm and this x-axis, or is it between this terminal arm and this x-axis? Okay, and whenever you find yourself in a situation like this, always remember that the reference angle is an acute angle, so it has to be less than 90 degrees. Okay, and I think that's what they mention in this fancy definition. So it's an acute angle. Okay. So you kind of have two plausible candidates over here, but as it turns out, it has to be an acute angle. So it's this and your x-axis over here. So we're interested in this angle. Okay, so theta r is the same as your standard position angle. So it's 75. Okay, what does this tell you? This tells you that when you're in the first quadrant, your standard position and your reference angle will actually always be the same, okay? Only in the first quadrant. In the other quadrants, that's not the case, but in the first quadrant, they will be the same, okay? So now let's do the other question. So 240 degrees. This is x, that is y, 240. So that's 180. And then it's very close to 270, right? It's just 30 less. So maybe something like this, okay? So this over here, guys, starts from here all the way there, 240 degrees. This is your standard position angle, right? But remember that your reference angle has to be between the x-axis and the um, terminal arm, and it has to be acute, okay? So we're talking about this angle over here, okay? So this one. So how do you calculate this, right? Again, you always have to do the bigger one minus the smaller one. So we have two arms, this one and that one. Which one's bigger? This one is 240, right? Based on the information that we're given. And this one is only 180. So theta r will just be the bigger one minus the smaller one. So bigger is 240 minus the smaller one, which is 180. And if you work this out, it should give you 60 degrees, okay? Yeah, so hopefully this kind of makes sense. Please, as I know this is simple as this looks, I want you to do the homework, right? Not that many questions. They're simple questions. Try this out, and if you're getting the right answers, then that means you understood this. If you're not getting the right answers, then please send me an email, okay? Because I went over this fairly quickly. I didn't want to bore you with a long video on the very first day back. But yeah, just do your work, understand you know how quadrants works, how standard angle works, and how reference angles work, and then you will be good for Tuesday and Wednesday, okay? Because that's when it starts getting um, fairly challenging, okay? So don't underestimate this unit, please, okay? So thank you so much for your time, guys. You have a nice day, okay?